just, I believe today, but possibly not an issue.
How big was it at this stage?
Maybe, trying to run back.
It wasn't as big as this one, was it?
Yeah, that doesn't.
This is the biggest one.
This is the
one's
big
like
one.
6.
This is the, that's right,
one,
this is
yeah.
the one that is big, you're right.
Was this 11 or 10?
This is 12.
Oh, 12. Yeah.
All right. So what do we have here? We've got a couple of things. So here's our average prices. We've got the, let's see, what are we doing? We're doing the channel price discrimination and so we're gonna tab gen and create those markets. I'm gonna rename them. And we started really simple with basically a dummy variable regression, right? So in the question, which one is this? So this isn't the subset.
No, a problem that I had was deciding whether, in the first question, whether to use the subset
Ooh.
or whether to just do the full, use the full data set of all prices across channels instead
Yeah.
of using the subset.
That's a good question. Which did you want? Because I saw that, well, I began doing it with all the data,
Mhm.
but then I read at the top of problem set 12's introduction. Where is it? I'll get that sentence right here. It says,
Are the problem sets weighted or are they based off of points?
Just pure points, pure percentage. So even the ones that are 200 are still,
So we can add up all our own scores and figure out our grades that way.
yeah. Or, yeah, that would. All right, so back to this. And we said this was 12, right? Data.
what's that thing you were doing there? You had a mouse pad.
Just yeah, no, you can do this. It's just rearranging.
Oh, I see. Like a selector where you want to put cells.
Yeah. I don't like it when I have the command stuff on both sides because it takes up too much room. All right, so this is the wrong one. We want,
Wine sold in all three markets.
sold in all three markets, so we need the markers. Still need that. Here is subsample.
In the problem set, you asked for a histogram, and that was the first data, that was the command hist, HST.
Yeah.
Okay, good.
Okay, so I got those. So the first thing you're asked is to look at average prices. And there's your average price. Now how are we gonna test So what do we got? You see they're different. And they're different in the direction we want them to be, well, we expect them to be different. Are those differences statistically significant? How do we test for that?
You have to do that in a regression. 'Cause
Yeah,
yes,
so it's that regression there.
CT.
So it's just a pure dummy variable regression. Prices against the two dummies.
And that's basing it only on a T-stat score, right?
Yep, and that's the only way we can test, for,
It wouldn't have anything to do with standard deviance, or,
standard deviance.
standard deviation.
I like the other deviant, I like standard deviance better. Standard deviant behavior.
For a moment when you had asked that question, before I ran the regression, I was wondering if we were maybe supposed to base it off of the standard deviation from the table, but then I thought, no, probably not, I went with a regression.
No, we probably could have, but yeah, this is easy. So it's, and we should get the same results. So $9.07 for grocery stores, which is our constant. And then these are the differences. So if we add this, that should give us $9.34. If we subtract this from our constant, which is grocery stores, we should get $8.41.
So if you don't put the M1 and 2 and 3, that's what's giving you your subset?
That's our subset.
Okay, because I did it without that, I got the whole thing.
Yeah, so that's our markers. Those are our markers that indicate they're sold in all three markets. And then, we put 750s in, 750 in there also.
Also, this one had to be at a level of 99%, because doing it at 95 would be changing.
Yeah, that's right. So did it ask for 99%?
It did ask for it, yeah.
Okay. So that was easy enough, we just put that level in, and I think someone asked that, so.
If you don't have it, it was good at 100%, right?
No, no, it'll give you 95%.
Oh, it does?
So 95%.
That's the default?
Yeah.
I have a question about the, we did that with forecasting, correct? Or is that?
We did something similar, yeah.
Okay, so is it completely different than the forecasting?
In forecasting, we created a 95% confidence interval around our prediction. And this is similar. This is a 99% confidence interval around our coefficient.
Is that to do with margin of error, or is it completely different?
It has to do with margin of error, but prediction margin of error and this margin of error are a little bit different. So it's the same concept, it's just applied to something else. So in the forecasting, we constructed a 95 or 99% confidence interval around our predicted values. And here, these are 95% confidence intervals around the regression coefficients. Yeah.
Do you mind running it with the 95, level 95? I didn't see a difference between when I did it with 95 and 99.
So you,
The only thing that changes.
these won't change.
Just the interval in the bottom right.
Oh.
Only these will change.
Ah, okay.
Yeah.
I was looking at my outright, these look exactly the same.
Yeah, no, it is exactly the same. So, yeah. And the T-stats are so high. Remember, the difference between a 95 and a 99% confidence interval is a T-stat of 2 versus a T-stat of 3. So, in essence, these are way beyond 2 and 3, that they'll be statistically significant. You had a question?
Yes, you have to do that same, you have to add that to the graph bar as well.
To add
When you
the,
do the graph bar, you have the same thing, you have to do the same graph bar, 90 equals, you have to do that. whole
yes.
thing.
So everything is gonna require us to do that. Now, one way to minimize your, although you should be copying, you can copy and paste this, but one way to minimize it is to create a data set that only has all these values.
Got it, and
So we can drop everything that isn't sold across all three channels.
Out of the data set that is back there in
Out of this data set, yeah.
So how do you do that?
How do you do that?
which one is shorter?
Well, one won't require you to type this every time. So if this is the subsample we're gonna use, that is sold across all three channels, excuse me, 750s, and then prices and cases positive, then we'll get the same results, but we won't have to type in those qualifiers every time. And it will reduce your data set from, let's see, from 632,000 to roughly that 79,000. So everything will run faster. And just to show you, let's do a whiskers, box and whiskers, which we know.
How do you get that on that one, cause on the bar rep, I figured out to do the, I don't know, you put that B label
Yeah.
R again, but how do you get that on the other one, the whisker one, how do you get it to print out the value on top?
So for the bar graph, we have that. Make sure so B label, will give us, do I have B label in here? B label bar. So to put it on top like that,
Yeah, but on the whiskers one, or whatever you call it, how do you get that?
I don't know if I did
Cause
that.
I think I tried to put it on, I used the B label, and I think it just ignored it.
Yeah, I don't know
Put it
if,
back, but it didn't really,
No, we didn't have labels on top of the.
yeah, I don't know if we had those. But, let's do this, okay, so that took a couple of seconds to generate, right? And let's run that regression, well, let's just look at that regression again. So if you wanna minimize your commands and create a data set for the problem set that only has these values, right? Only has products that are sold across all three markets, 750s, and positive prices and cases. We can borrow this if statement. Copy. Now, one of the things I said earlier was the simplicity of stated commands, which I know you don't believe. But if we wanted to keep only those values that satisfy this condition, guess what the command is? What's that? Keep, exactly. If we do that, it's gonna drop, remember this was, what did we say it was, 632,000? And we really only want, what? Those 79,000. So if we just say keep if, now if I type count, we should have, oops,
so is that permanently delete them?
yes. So save this as, as a different file name. So where's our count? Count. So 79,835 after we dropped 79,835. Now, let's look at the speed at which it'll generate that graph. Still took a second, so.
So then we would only need to type the first part of it, graph.
So now we don't need, yeah, exactly. Oh. So now we don't need all that other stuff. Now for me, I'm gonna keep them in there because I don't wanna delete them all out. But it'll be, right, they're still in there and it doesn't matter, it's just superfluous, it's unnecessary. So now everything we do is gonna be for products sold across all three channels, 750s, and positive prices and cases. Because that's what the entire data set consists of. But yeah, I would definitely, bless you, I would say, save this under PS, or, you know, PS 12, B or something like that, so you know, so you have a subset. Although you can always re-download it, so it's not that big of a deal. But yeah, it is a permanent, if you don't save it, it's not gonna, it won't be permanent, but once, if you do save the data set, it will be permanent. Okay, so we run that regression. I'm sure I asked you about percentage differences. Yeah? And then that's the regression there. So we saw the dollar differences, now we got the percentage differences. And 8% cheaper at drugstores and 4% more expensive at other stores. And again, both are statistically significant. Yeah.
So what does the constant indicate?
The constant is our base category,
Yeah.
which is, which is what?
Grocery
Grocery stores, yeah, which is grocery stores.
What does the 2.11 mean?
It's the log of the price of at grocery
Okay, hold on
stores.
a second.
So, you know, it doesn't really have much of an interpretation.
Yeah.
The really, the beauty of the interpretation is for the dummies, and those are the percentage differences. And that's nice. So yeah, it's the log of whatever the price is. And I don't know what that means either. It's just the log of price. All right, what do we do next? We ran a regression to, so what do we do next?
What a histogram.
Yeah.
Because he didn't show us we get graded harshly if the layouts are slightly different.
Histogram, here it is right here.
I did mine the other way, so I got three.
The default-
Going left to right.
Yeah, the default is probably to put them, 2 and then 1.
Yeah, it doesn't
Yeah.
have two of them.
So I put the option, what's my option?
Vertical, I think, layout.
Columns 1. So I want 1 column. And the reason I want that, and you're not gonna get marked down for not having that, by the way. But the reason I want that is because I wanna see if these distributions are shifted over relative to each other.
I did mine the other way, laying them out horizontally, so
Horizontal,
they're
yeah.
really tall, and it's kinda hard to see with naked eye, so then what I did was I put
So you put row 1.
I put a line, yeah, I put them row style, yeah, so there's 3 in a row, and then I put a line down the middle at LM price 2, so it would help you to kind of visualize if one was larger on one side versus the other. So that you can see that there's more stuff on the lower end of drug, but on the higher end for liquor.
Yeah. And I think this one makes a little bit more sense.
Yeah, that one probably.
A little what?
At the end, I could, it was, when mine was doing it 2046 or something like that, I couldn't get it to,
What's the part next to that?
These?
X label.
X label.
See where it says X label?
0 to.
You're talking about these though, right?
Yeah.
Yeah.
That means X label starts at 0, goes to 30 by increments of 2.
By increments of 2.
I always go in it and try to like muck with it.
Yeah.
Does
That's
it
the
have
one.
to be put, does it have to be put in any certain order?
No.
Can it even put after the percent or not?
As long as it's after the comma, you'll be fine. Yeah, you can put it in any order.
So I never could get very small to work, I could only get tiny to work, is that because you have X rescale, or is that not any part of it? I'm just screwing up on something.
Couldn't get V small to work?
I could get tiny to work.
There's something tinier than tiny,
There, okay.
minuscule. You have to literally write the word minuscule in there, but it's minuscule. It's really, really tiny. V small didn't work, wow. That's
But I
weird.
didn't use that X rescale thing.
No, that shouldn't matter. That
You
shouldn't
can,
matter.
you can also, if you start graph editor, under file and use start graph editor, then it opens up all those commands, it's kinda like playing with a graph like you do in Excel. And then you can just click on words and find how to resize them. Words or the rows of the value, so.
What are you clicking?
Up on
The graph
file,
editor.
Yeah.
graph editor.
Yeah, that's.
Oh, yeah,
On the menu
that's-
bar, top
that's
file,
what I do.
yeah, or that button right there as well, same button.
That's what I, yeah.
Start graph editor, then you can click on stuff and it'll give you options to change the display.
Yeah. And V small should be in there, so click on this. Yeah.
Yeah, right there, label signs, B small, tiny, minuscule, huge.
Tiny,
I have
and
nine, there it is.
minuscule.
Zero.
Zero is, yeah, I'm not sure what zero is. I haven't used zero. But V small should, did you put very small or V small?
I don't remember.
Cause very small won't work, but V small will.
I didn't put a dot after the V, I just put.
No, no,
small.
there shouldn't be a dot. That is strange. There shouldn't be a dot.
Okay, I didn't
Okay.
get that.
Can you discuss the interpretation of that graph?
Yeah, what we're trying to do is, and I actually prefer the box and whiskers graph to this. But literally, we're trying to look at and see if these distribution, remember we got difference in means, right? And we wanna see if these distributions are shifted over relative to each other. So does liquor look like it's shifted over relative to food? And does drug look like it's shifted over to the left relative to food? And my answer is this isn't that great of a graph.
Yeah.
It doesn't really show us, I think, what we want. I think the box and whiskers graph conveys that information better. But one of the reasons why we look at these is important. Because we want to see kind of these tails, right? It could just be one observation that's pulling out that mean, and we want to see if that's the case. And I think that to better demonstrate what we're trying to look at, the box and whiskers graph is just a better graph. Because now, now we can again see the outliers, but you can kind of see the step, it's small, you can see the step function of those boxes. And remember that the box is basically the middle 50% of the data. It's called the interquartile range. It's the middle 50% of the data.
So with those dots up there, be like the outliers?
Exactly, those are the outliers. Those are those tails that we were looking at in the histograms.
And the box is kind of that middle, sort of.
Chunk of data.
First standard deviation of a bell curve. right?
Yeah, exactly.
So exactly, from the mean, which is the dark line in the middle of the box,
No, that's actually the median.
the median.
Yeah, you can't.
But then-
median.
There we go, yeah, the median, and then it's 25% of the data above it, and 25% of the data below it.
Exactly. And this is the middle 50%. So kind of like what he said, that one standard deviation out, but it's not exactly 68%. And even here, it looks real subtle, but we know it's statistically significant because we ran the regression, and the t-stats showed that they were statistically different from each other.
But the outliers look like they're all above to me right now, not below, right?
Yeah.
Or am I misreading that?
No, you're right.
So then that's not 25%, that would be 50 and 20 and 50, or 50 and whatever, because you don't have anything below it. You're saying that the box represents the 50%, correct?
The middle 50%.
Middle 50%,
Yeah.
and then the outliers on the top are the 25%.
But it only shows the outliers that are beyond the what's called the whisker, which is this thing.
And that whisker reaches to 1.3 standard deviations? Is it
Yeah.
in each direction?
Yeah.
I Wikipedia.
And it's gonna be different from, different programs. I think Stata uses 1.3, but some other programs might use 1.5 or something like that. So-
Okay.
Do you want us to comment on like skew?
Not really. I mean, the distribution shows the skew. Basically, the main thing we're trying to say are our average prices different across the categories. And as subtle as that is, we do know, based on the regression results, we do know that yes, they're different, and that difference is statistically significant. And these are prices, not log prices. The log graph actually looks better. The log graph. Because remember, the log graph compresses the data. So the log graph will look. Yeah. And again, notice it only shows the outliers above and below the whiskers. And again, here, it's not. You still see that step function relation.
Does the command change to, Ellen Price and Ellen Cases?
There's no cases here.
Does it change to Ellen Price?
Yes.
Yeah, we're looking at log.
It's just regression of LM price by market, over market.
These are just box and whisker graphs. This is not a regression.
You're right.
So there's no regressions here.
Don't you still have to say it's Ellen Price over zero?
I'm sorry, one more time?
You still have to say Ellen Price over zero though?
Ellen
If
Price.
we didn't clean up the data set.
It's pretty close to the outliers and all.
We're gonna say cases over zero, so that we.
Oh, no, we can, as long as price is over zero, log price will be fine.
Correct.
Okay.
It's just our outliers are all. Which doesn't make a difference.
All right, here's that same regression result in logs. Is that it for the summary and statistics? When would we do it? So to look at elasticities, we're gonna generate our price is already generated, so let's generate cases. And again, we've been running these kinds of regressions for a while. We've got
This one is good, though, to say about the positive coefficient that you get for
yeah, so we've got log price equals beta 0 plus beta 1. And I'm not sure of the order, but it looks like I've got drug, beta 1 price plus beta 2 drug plus beta 3 liquor plus beta 4 liquor price plus beta 5 drug price. So now we can left plus our error term.
That'll be LN cases on the left of the equation.
And then we have
And it's based on Ellen Price.
excuse me,
It's based on Ellen Price.
is beta
They all-
1.
They're all logs.
Yeah, beta 1.
Oh, yeah, I'm sorry, they're all logs.
Is beta 4 and beta 5 switched?
Yes.
Beta 4 is
Oh,
1, 2,
compared to-
3. Beta 4 is liquor price,
Yeah, on the board,
is drug price.
Yeah, drug price versus.
Yeah.
Are we supposed to include I.month in this regression?
Yeah, and then you got your months.
In the instructions, it doesn't ask for anything about seasonality or anything like that, so I didn't know if I was supposed to include it.
It says nothing about that?
No, not in this one, Simon.
That's interesting. Let's see. are business intelligence, and we are 12, so let's see, estimating price elasticity of demand. Yeah, it doesn't necessarily say you have to put monthly in there. But you're gonna almost have to for the inventory management and price optimization. Okay. Either way, we're good here. I didn't put it on the board. So again, kind of just the mathematics that, what's our base category? Grocery,
Yeah.
food. The equation will be log cases equals, everything's, all the dummies zero out, right? Beta 0 plus beta 1 price. Now, once I write that out, it's easy for me at least to understand what the price elasticity of grocery store sales is, which is what?
Negative 0.57.
Yeah, negative 0.57, right?
Like roughly a 0.5% decrease in LN cases.
And the interpretation is for every 1% increase in price, quantity demanded would fall by 0.5%.
Right, so if you define that, you would say a 1% increase in the LN price.
No,
No? Not the LN price, just the regular price? Okay. Actual price, not LN price. But it results in a 0.578% decrease
correct,
in actual cases, not LN cases?
correct. And for drug, you would get log cases equals beta 0 plus, well, let's look up here first. Plus what?
B2 drug.
Plus beta 2.
And
Plus
beta
beta
5.
1 plus
Beta 5.
beta 5. Log price, right? So once I write this down, I know how to interpret I know how to get my my price elasticity for drugstore consumers. It's gonna be beta 1 coefficient plus the interaction term of drug and price. So it'll be, I can't do that in my head. Display this. And then the interaction with drug and price. Do I need those constants and all that stuff? No.
Not in the elasticity, you
Yeah.
can calculate cases.
So price elasticity of demand for drugstore consumers is 0.98, which is higher than 0.57, which means that drugstore consumers are more price responsive. So now, for every 1% increase in price, drugstore consumers are gonna buy almost a full percent less. Whereas grocery store consumers are only gonna buy a 0.5% less. It's consistent with the theory that I put forward.
Okay, I know drugstore from the slide, like B0 plus B2 plus B1 plus.
It doesn't matter.
Okay.
Because I could rearrange these a million different ways, and as long as you know what it means, then that's all that counts. So how you put them in the regression is gonna be different than how I do.
Ordering of it.
Yeah.
Okay, this is where I screw up on the equations. Remember I was telling you I have a problem?
Yeah.
The equation versus margin?
Yep.
Because I wanna put all four numbers in.
You wanna put all four numbers in.
The B zero, B two, B one, and B five. Yep, I do.
Two, B0, B1, B5.
And then-
You
and
wanna
then-
put all four numbers where?
In my calculation for LN cases to understand drug. So I want my B zero, which is, my constant.
So you wanna do all these,
You bet,
0, 2, 1, and 5.
yes.
That has nothing to do with the equation.
Okay, so why? That's what I'm missing.
Because price elasticity of demand is the coefficient on price. And the only two of those are coefficients on price. The other two are the constants, the intercept.
Okay,
Right?
now, yeah,
Now it makes sense?
yeah.
But I think if you had written this out, did you actually write these out?
Yeah, I wrote it out, it's in the problem set. I wrote it out and I put in all the numbers and I talked myself through it, that's why. But yeah, no, I didn't, I
Yeah,
didn't
so
connect
this-
the constant
This is our price elasticity of drugstores,
and just be one.
and this is the price elasticity of grocery stores, food stores.
I got the first one, and I'm still tripped up on the drug. Why, so the B5 is the liquor on price.
It is on the PowerPoint, but
No,
it's
I'm
not
saying
here.
here, if I'm looking 1, 2, 3, 4, 5, 8, 1, 2,
Okay,
3,
but it
4,
is there,
5.
but it's not here.
Oh, I see what you're saying. So I was.
All you have to do is look at the coefficient.
Okay, I wasn't looking at what you wrote on the board, I was trying to match it with up here, saying that you're putting drug with liquor and then throwing, but now I see that you're.
You have to look at the
there.
coefficient of drug
I,
price.
okay, now I see what you wrote up on the top of the. Got it. So I just wanted to know, like, the drug goes to drug.
Yep.
And the liquor goes
And that would make
liquor.
sense if you had actually written it out. Did you actually write it out?
Yeah, so I think actually I did it right. It just
But you're
got-
referring to the PowerPoint, which tells me that you're not writing these out, and that's why you're getting confused. Because you've literally got the PowerPoint, the picture of your PowerPoint on your phone right now.
Yeah, that's what I mean, I'm kinda going back and forth, but I'm looking at how I wrote down here, and I'm looking at my V4, and it's matching my equation.
So, and again, as long as it's making sense to you, but if you just write these out, it'll make sense. And I think if you're doing what you're doing, you're just looking at the PowerPoint and you're trying to say, whatever it is, it's B4. B4 could be a month. I could have put January there or something, but you're gonna put B4 irrespective.
Yeah.
That's the bad part. That's where you're just not working through the problem. You have to go through this process. I go through this process, I do it every lecture, and this is what you have to do to at least to make some sense out of this. You can try to hurry through and not do it, and I think that's where you get tripped up. If you just kind of take your time and slow down, it'll be faster in the long run, because you won't be tripped up over messing things up. There's just no way, again, that's for me. I understand it by writing this out. Notice I'm not just reading these off, I'm actually writing them down. Oops. Liquor is going to be cases, beta 0 plus this equation, it's gonna be beta 3 plus, beta 1 plus beta 4, whoops, plus log price. So, price coefficient, and then coefficient of log price and liquor interaction. So it's gonna be that 0.57 again?
Yep, negative 0.57 plus the 0.67.
What did I do? That's and then the interaction of liquor and price, that. What the heck is that?
Display.
What did I do? That's pretty cool. How did I do that?
Display.
Yeah. But that does go, how did I get that? Display. This is the hard part of econometrics. Learning how to spell display.
Discipline.
We normally don't learn how to spell display until like PhD level econometrics, so. I'm kind of rushing you guys to get
Yeah,
here.
this was an accident. Discipline.
And again, it is
Positive.
positive.
That means the more you charge, the more they buy.
Exactly.
That doesn't sound like law of demand to me.
It doesn't, it doesn't.
So how do we take that? But its T-score is significant, very significant.
Anyone else get this?
I
Almost
have-
a special case in that people go into liquor stores because they're probably supplying liquor. So they're a little bit less responsive, except for the price of the
No, it really doesn't make any sense. It violates the law of demand.
Yeah, if that's the case,
Yeah.
charge a million per bottle, and they just keep
And
charging to infinity.
It means you should raise price, well, remember, price elasticity is a variable, so it's gonna eventually go negative, but,
So is this saying that prices are too low in the current liquor stores?
no, it just means that it doesn't make any sense and there's something wrong. But, that's fine. Regression, remember, we're dealing with data, we're dealing with people, we're dealing with numbers. Data is not always gonna work out nicely. And this is an example of strange results. Now, it can be fixed, but it's not gonna be fixed in this class. There's a problem with what we're doing, it's called endogeneity. And you solve that by doing something called instrumental variable regression. And we're not gonna do that in this class, it's something I do in my quantitative marketing class, and it's something that I might cover in the 581 class, but in this class, we're good with where we're at now. We're good with saying, look, we got a positive coefficient, it doesn't make a whole lot of sense, but that's what the results are.
So if-
When you have a complementary good.
But this is the same good, these are,
Oh, yeah, okay. So when we come across this, which it actually gets more extreme when we get to question 5, for liquor.
yeah.
So we should definitely mention this in our,
Doesn't make sense, yeah, I
just
think
say
so.
it doesn't make sense.
It's the wrong sign.
Cause I think that's probably why and I'm sure a few others really struggled with question 5 because it didn't make sense. So I was trying different ways and I tried 3 different ways and they all gave me answers. And then I confused myself because I was like, well, I don't know which one is the right answer.
If you're interested in the problem, perhaps the best paper on instrumental variable regression just happens to be on our website. And it's called Estimating the Demand for Wine Using Instrumental Variable Regression. So it's a advanced topic that we're not gonna worry about, but it's a pretty common problem. It's a pretty common problem. And it's not just for wine, wine's the example, because that's what we have the data in. By the way, Ryan Huffman is now the Director of Digital Analytics at, you wanna know what VSP is? It's an eyeglass company.
Vision service.
Yeah.
Yeah.
So he's the Director of Digital Analytics there. I just talked to him a couple of weeks ago. He's barely 20 some odd years old, but, I think, and he's probably not gonna be happy if I tell you, I think he's making about 150 grand, a couple of years out of school, so he's doing all right. Co-author on this was my research assistant. This paper is used in graduate school to teach people instrumental variable regression, so. Obviously, again, it's probably the best paper in this field, but, I'm biased. Once again. But we do use that paper in other classes. All right. But you will get, this is statistics, this is real life, it's real data, and you will get awkward results. And it's really important to recognize that doesn't make any sense. something's wrong here. All right. What do we got next? We estimated the price elasticities, we got that. Demand estimation, well, we already did that for Ravenswood. Ravenswood is a weird situation. If you look at Ravenswood, so if you just, oops. If you look at Ravenswood cabs, you see that we have two of them. And the homework specifically asks you to look at
California.
California.
So that means don't use Sonoma? Because that brand is actually called California, Cabernet Sauvignon, so I thought that meant don't use Sonoma. Otherwise you would say California and Sonoma.
Well, this is strange because there's two Californias. But one of them occurs a lot more frequently in the data than the other. Again, I didn't do this on purpose, but I like the way it came out. And
I was trying to get it specifically to what you meant, so I actually went into the data and took the what's it called? The UVC
yeah,
of both of them and Googled it to see their name. And the first one was actually called Ravenswood Cabernet Sauvignon California. The other one is called Ravenswood Cabernet Sauvignon Sonoma. I didn't see California mentioned in the title, so I thought that you didn't want that UVC to be studied.
no, if you look at the, where's the one with just the SKUs, all the SKUs for Ravenswood? I should have a tab for that. Tab item. Let's see what's-
Did anybody else do that?
No, I just picked the one that wasn't the blend.
So you measured both of those kinds of Ravenswood?
No, one was a straight cab, one was a blend. I picked the cab.
There it is.
Yeah, I got a brother with chair.
Look at these clothes. Are they really different? Those SKUs closely. Are they really different?
One has an S and a few more.
One has an S, one has a VS, and then V dashes.
Look at the word Ravenswood. S. CV is the same, California is the same. Here they put the VB together. It's the same SKU. Ravenswood changed the SKU. It's the exact same bottle of wine. This happens all the time, not just in the wine industry, in every industry.
It's anytime they change the label, they change the UPC,
Yep.
because it's technically a different product.
It's a different product.
So if you change like the
The logo.
the ingredient, and you put 2 pounds more in the bag, you have to change the UPC.
Yeah.
So that's why I'm thinking like a marketing person, if it's a different product, a different label image, it is a different thing. So I went for the one that has a product type of label, looking at it as a consumer in the store that says Ravenswood, California Cabernet Sauvignon.
But there is no Sonoma here. It's Ravenswood, Cabernet Sauvignon, California.
Maybe you're right, I saw something.
I'm doing the tab, and I'm actually getting 2 line items for non-cow.
Yeah. So there's non-California cabs.
So how did you get that on your, because you already scrubbed the data, or why is it,
Where I dropped
Yeah,
500,000.
you dropped that stuff
Yeah.
back.
But these are actually the same SKU, and this is a really, like I said, I didn't do this on purpose, but I think it's a really good example of if you just look really close, they just put the S in Ravenswood and they, put the VB together there, it's just,
So how
it's
could you,
stupid.
what would you say, if you didn't scrub the data to not exclude California?
That's why I specifically said California, because the other ones are, might be the Sonoma ones.
So how would you take them out?
You don't, you just use this SKU instead of the,
Yeah, when we do the command.
yeah, you specify this SKU.
Both of them.
Well, you can do one of them. Actually, I just had to do one. So you could do both of them, but all you have to do is if item equals, copy and paste that.
Because it's gonna pull both of them.
No, it won't, but it'll, you can put both of them, but I don't think I had to
So
do
we
that.
only need the 108.
So use the 108 one, yeah. The 24 one wouldn't work,
I just think that one.
but you could do both.
No, that's okay.
But I think the interesting part is that it's the same SKU, it's just that Ravenswood changed it by just a hair too. And it, you know, this is why we look at the data.
So we only consider one of them, not consider both of them?
If you could do both, yeah, do both.
Okay,
Did you use both?
yeah.
So you put an or statement? Perfect.
Why would you put or, you want and, right? Because you want both.
No, because you can't be and, you can't be one, but they are the same thing, but it's an or statement. Because you can't be both of them at the same time, although they're the same. So that's, so we've got two things. We got this weird regression result, and then we've got this weird data analysis. Did I do the tab gen market stuff already? We did this already. So you figured out the schemes were the same. That's awesome. Anyone else? Just you two? You guys did awesome? Yeah, that's good, that's awesome.
I wouldn't have, because I was looking at it by item,
Yeah.
the product item name, and I didn't know that there was a Ravenwood without an S, little,
Yeah.
RVNWD and RVNSWD, whatever, I didn't know there was a second block of Ravenwood. So I only analyzed the first one. I don't-
This is,
I-
yeah, like you said, this is just, it's common in the data. It's every product, if they change the label, then they change the SKU.
Okay.
Which is one of the reasons why in wine data, we don't have, vintage, because every vintage would have to have a different SKU. And, it would be nice to have the vintage, because different vintages are different. But wineries are just too lazy to change the SKU each year.
So being that I got the wrong data, then is that gonna cause my entire homework the rest of the way to be all wrong? Or if I still use the right techniques, even with the wrong data, do I get some points back?
Yeah, it's not a true and false question, so you get partial credit. All right, so here's our regression equation. You're gonna use this for both the inventory management and, the price optimization. It's the same regression as this, except we get rid of the logs, right? And then, but we need one more coefficient. And in the questions, which coefficient is that? The question's real specific.
January.
Yeah.
It says use the last month of the data, right?
Yeah.
And what is the last month of the data?
July 25th.
January 2010.
January 2010? Anyone else?
I thought it said July, no?
It said use Jan-
Table what? Month? We're looking for
And
So
then
I
it's
said,
sold.
mean price and,
Is this 10 or 2010? Or do I have?
Ten.
Yeah.
10, yeah. So mean price and mean cases. So there we go. So we've got our mean price and cases in January 2010, which isn't the last month of the data, but that's fine, the instructions are clear on that.
We did it by table with the offset, because then it gives you
Absolutely.
drug price
Yeah.
later.
Yeah, right. And you put market here?
Yeah, and then we did, if year equals 10, and then we did if month equals 1 instead of putting.
And then you
one.
get, yeah, so it'll
So it just,
minimize
it
that.
only gives you 3 results then, yeah.
Yeah.
Get rid of the month.
Much better.
You don't wanna still table monthly, do you? You table market if you're equal to
Yeah.
monthly.
Get rid of
one, and not one.
You could do, well, this works. But yeah, it'll look better if you do it the other way. Boom. Same result.
Yeah, no, I got it.
All right, what exactly is the question? Find the average price and quantity sold, okay, so we found that. And then suppose Ravenwood wants to set a uniform price of $8.99. So basically, we see that the average price is $8.59 and $9.63, and we want to set price to $8.99.
Are we not, we need to put something in there relating to the one in the table?
You're right.
Item,
And where is it? So we don't want another if, but we can put and. All right, so $7.99, now $8.69. So we've got our three prices in the right direction. Now we want to set price to $8.99 across all three retail channels. What do we do now? How do we answer this? Oops, I want that. So we've got cases. One price, that's 32. Drug. That's 33. Liquor. That's 34. Oops. Drug price. That's 35. Liquor price. That's our haircut. $8.99. All right. How much do we ship to drug, food, and liquor stores? we run this regression. Which is not a raw regression. Oh, that's right there. Yeah. So how do we find out how much we ship to grocery stores, for example? What do we gotta do? Plug it into what?
To the coefficient price.
Into the whole thing?
No, just for each grocery.
So we have to do the math part, right? Yeah. So for food or grocery stores, we've got cases equal beta 0 plus beta 1 price. And then we just plug in $8.99. Wait. Getting something. Don't we have to put in for January? Don't we have to put in a dummy for January?
You know, just.
When your I went through that, and then your constant is already January.
What do you say?
I used the margins command, so I did like margins comma at price equals 8.99, and then just did like if month equals 1, if year equals 10, and did it that way.
Here.
But to do the year, to include the year in the margins command for it to work, I had to put year in the regression. So I did I dot month and then I dot year.
You didn't really need to do that. All you had to do was this. But do we still need to put a dummy for January? What'd you say earlier?
I don't think we need to because the IMA does seasonality, so it's already accommodating for January and past data. So the constant right there is January.
Yeah. So remember, all these dummy coefficients are the difference in sales in February, March, April, May relative to the omitted category, which is January, which is gonna be in the constant. So we don't need to put a dummy here. If I had asked you for, a different month, like August, then you would have had to take the coefficient for August, right? And then add that to your constant. But you didn't have to do that. Which is probably why I asked for the month of January.
So if you did margins and did each regression separately, like for each market, and didn't have the I month, would you still get the same thing?
No. So you're gonna run 3 different regressions for,
Yeah, like, for each different market, and then margins at price equals $8.99. We had done something like that before, so I
No.
thought about doing that.
never, not once. I guarantee you. We always use, and the reason why we always use dummies and interactions is so we can see what the difference between the markets are, across the markets. Because if we run separate, regressions, we'll get coefficients, but what we won't know is whether or not, for example, this isn't our price elasticity, it's our slope, but we won't know if this number is statistically different from our base category. So we'll get numbers that are different, but we won't know if they're statistically different. Also, if we were to run separate regressions for separate markets, we slice up our data set. So we get smaller samples, we can't compare them. That's why we've never done that before. So
Okay.
if Is that right?
Well, I think,
I'm
well, we
almost
did it
certain.
with, like, Clos de Bois, I wanna say, and you said if price is this, then how many cases would you sell?
Yeah.
So it is a different thing we're doing than.
Well, all we did was change, like, the price was this, then we're gonna plug that in here, then I give you another price, you plug that price in here. And so, I think what you might be confusing is that we're gonna have, right, 3 different regression equations here, but they all come from one regression.
Yeah.
And that's why I constantly say you gotta go through and literally, just write these out separately, so that it reinforces in your mind that I'm not running 3 regressions. I'm running one, and I'm getting 3 separate, regression equations from that one. And I think that's, like I said, I think that, and I said this at the beginning of the class, I think that's the source of all the problems, is people aren't just going through the process, the act of writing it out. It's too much, I think, video and too much fun. I think there's a place for that, but it's a complement and not a substitute for note-taking and writing all this stuff out. We're gonna get 3 regression equations, just like we did with the elasticities. We plug it in each of those, and we'll get an answer. We invert these, plug in the cases, because the next question is the same question I asked probably for Clos de Bois, was like a price optimization question was, for the quantity sold in January 2010, part A above, find the optimum price. So, for what quantity sold in January 2010? For January 2010 was here, right? These are the quantities sold in January 2010. 362 cases at drugstores, 7,000 in food, and then almost 3,000 in liquor stores. For those quantities, invert this regression equation and just plug in for cases, and it'll spit out the price. You can't do that with margins. But if you outranked it, you can set up that equation pretty quick, pretty easy. And that's literally how you should do price optimization. Which is why it very rarely gets done, especially in the wine industry. Because it's not really clear. But we've been doing it, again, this is the 3rd time we've done it. And people are still having trouble, so. If you've never done it, it's gonna be hard. And that's it.
Can we go over,
Hmm?
can we run over, the price optimization, can we do the price optimization?
I don't wanna give away everything. Yeah.
Okay.
Okay, so that equation right there, you take the food and the cases, and divide them, and then divide that number by that equation, right? Am I right or no?
You just solve this for price, like you did.
Just solve it for price.
And then what you're gonna get, again, I'll do it, this is the 2nd time today, but that's fine. You're gonna get beta 1 price equals, this is gonna be negative, so we're gonna move it over there, and this will be beta 0 minus cases. You divide both sides by beta 1, and you'll get price equals beta 0 minus cases beta 1.
Isn't it cases minus beta 0, because if you leave in beta 0 over
So this will be,
because that's positive, right?
it's a negative coefficient though, right, in the regression? So, the first time it's in.
I think it was like, looking up your room, somebody who was doing different regressions to see if it looked right. The gain in revenue, I guess I was expecting them to probably positive, but it might not be the case. Maybe if you were to use the optimum price, maybe it's not the best way to go in some cases.
Yeah, yeah. So, we test these things, we look at the models. What is our, we got pretty good R-squared on this one also. This was Ravenswood. Remember, there's a margin of error with these regressions. So, just like we estimated remember when we forecasted, we got a margin of error. When we estimated demand curve, there's gonna be a margin of error also. So what we're doing is looking exactly on this point here. Now, if you're doing this for your company, you probably want to calculate this margin of error and say, yeah, our price is within our actual price is within the margin of error of our optimal price. So,
Okay, yeah.
and it's the exact same process to predict STDP and, put the T-stat and all that kind of good stuff. So, I tried to minimize some of the stuff we did, but mechanically, it's exactly the same. Mechanically, it's exactly the same. And it's a pretty good model. It's a pretty good model. R-squared again. 96, that's insane. That is insane. Put some glue back together, it looked like stuff was falling apart, wheels were falling off, we're riding on the rim, or whatever you wanna call it. The things looked like they were going south there. Like I said, I think it's, the way you're trying to learn with the phone, the pictures and the video. I just think it's more of a detriment than anything else. If you use it properly, then as a supplement, that's probably good. But invariably, I've seen it over and over and over, not in just this class, but in my undergraduate classes, which, by the way, are 10 times more data intensive than this class. My quantitative marketing classes are 10 times more data intensive than this class. Nobody takes videos or takes pictures. They just know, they've learned by then that that's the wrong way to go about it. So I'm not gonna prevent it. The idea is you'll figure it out yourself. We're kind of late now, but I told you that at the beginning of the class. It's invariably people that do the worst are the ones that rely the most on that stuff. So, yeah, I don't know what to say. Other than, any questions? Does that sound like, you don't have to raise your hand, or I guess if you say so, but does that sound like your problem? You're relying too much on pictures and videos, and you're not actually writing this stuff out and having it, kind of absorbing it just through the actual process of writing? I mean, that's how I learn, so.
Exactly how it is.
I think like the past 2 weeks, because before the past 2 weeks, like I hadn't taken one picture, but the past 2 weeks, because there's been a lot of information that we've been going through, and I physically have not been able to write down what's on the slide before you go to the next slide. So that's why I've been taking pictures so that I can focus on what you're saying and not
Which is
just trying to
good.
do that, and then go back afterwards and fill in the blanks. with
Exactly, and then go
pictures,
back
that's
out and
what-
write it out, and I
Yeah.
think that's ideal if you do that. But if you're doing this and trying to do the homework, then you're gonna spend way too much time trying to figure out, well, that's beta 4, but beta 4 is a month and it just doesn't make any sense. It's, yeah, I'm all for technology, so, I just think, like anything else, you gotta use it properly. Use technology for good, not for evil. All right, so you got not another week, you've got another 2 weeks to do this. And hopefully, right, because we don't have class next week, right?